In this video, we'll explore basic processing techniques of picoSpin JCAMP data using the Mnova NMR software. We'll describe various processing tasks such as zero filling and apodization and provide guidance on how to set their values. We're going to discuss a lot of detail, so we'll have a firm understanding of how and why we apply certain processing functions. Because of this, we'll break the video into smaller, more manageable segments. In Part 1, we'll look at downloading experimental data from the spectrometer and changing the Windows file association for the JCAMP data file. Part 2 covers zero filling. Part 3, phase and baseline correction. Part 4, chemical shift referencing. And Part 5, apodization. For this tutorial, we'll use the latest version of Firefox within the Windows 7 environment and Mnova version 7.12. While there are many web browsers available on the market these days, picoSpin recommends the Firefox web browser for best compatibility with our software. Likewise, there are many versions of Mnova, but we recommend using version 7.12 for best compatibility with our JCAMP data. For a more detailed description of data processing, please refer to Mnova's user manual. Let's get started by downloading some data from the spectrometer. When we perform an experiment using the OnePulse script, the experimental data is stored on the instrument. If we name the run, we can access the data file by navigating to the Files page and selecting it. I'm going to select a recent experiment on propyl acetate. By clicking the named run, I'll gain access to the JCAMP data file. After selecting an experiment, if we scroll to the bottom of the Files page window, we'll see two download options. In the lower right-hand corner, the Download All Data button gives us the option to download a tar archive file from which we can extract the JCAMP data file. Alternatively, there is a clickable JDX file at the bottom center of the page which gives direct access to the data file. Let's work with the direct access file download option. And at the same time, we can set the file association for the JDX file extension to open automatically in Mnova when selected. Clicking the JDX file opens a standard Firefox download dialog box, giving us the option to choose a program with which to open our file, or to save the file to a download directory on the computer. If one opens this file directly into Mnova, we'll find that the JDX file is stored in a temporary roaming directory, making it difficult to properly archive the raw experimental data file. I'll choose Save As. Since my browser is set to download files to a predefined directory, when I click OK, the JDX file will download into this directory. If your browser isn't set like this, then you'll need to navigate to the directory of your choosing and place the JDX file there. My preference is to keep a pristine copy of the experimental JCAMP data locally on the computer, and usually I create a separate directory for each sample. For this video, we'll work out of the standard download directory. Mnova uses an easily recognizable red M file icon. Examination of the file icon tells me the JDX file extension isn't currently associated with Mnova. If I want the ability to open the JDX file directly into Mnova simply by double-clicking the file, then I'll need to change the file association. Let me show you one way of doing that. First, I'll navigate to the download directory. In Firefox's download window, right-click the file and choose Open Containing Folder. This will automatically open into the download directory. Now, right-click the file and navigate to the Open With option and select Choose Default Program. From this dialog box, choose the Mnova program and confirm that the Always Use Selected Program option is checked. Then click OK. Clicking OK will automatically open the file in Mnova. Now you'll be able to open JDX files directly into Mnova by double-clicking them. Likewise, in Firefox's Download File dialog box, the Open With option will now, by default, have the Mnova program selected. Mnova will automatically Fourier transform your JCAMP data on import, but we still need to apply some basic processing to the data. The tests we'll need to perform are zero filling, baseline correction, phase correction, chemical shift referencing, and apodization. All processing functions are accessible from the processing menu on the menu bar or from icons on the processing toolbar. Additionally, some functions are accessible using keystrokes. I'll point out when keystrokes are available, but mostly I'll use icons to access functions. So let's move on to Part 2 and zero fill our data.